Hello and welcome everyone. We're here to tell you today about how at William Hill we managed the extreme demand for Grand National 2021. In March, the UK government announced that the lockdown would be extended, and we didn't have a Grand National in 2020, and a lot of our products, platforms and services changed between 2019 and 2021. And we didn't have very much data on how these will perform under extreme load. The Grand National takes place on a Saturday in early April. The football season's in full swing. Because of lockdown, online demand had grown anyway on a Saturday, so we were taking more bets than ever before on a Saturday, and we needed to protect these customers. These were really important to us. And the first question we had to answer was, big, how many customers would come to William Hill and when they would come? Normally estimated, so using this formula, if you look at Boxing Day in 2019, it was at a 6, and Grand National was at a 9. Boxing Day in 2021, if we apply the standard model there, was an 8, and if we're going to do the maths, we get to 12, but that doesn't feel quite right. We're in a lockdown. We think Grand National is going to be bigger, so more people are going to bet online. So we decided to take a different model. What we did is we split our customers into different groups. The first group of customers is our existing customers, and this is our most important customer group, and this number's 8. Then expected Grand National load, this is pretty much doubling that load. So we're going to say that same amount of customers are going to come again. And this is what we're going to scale and tune our systems to. Over and above that, the load's a bit of a mystery. So there's a number of factors that can influence this. How many people bet online? We don't really know. No one's ever done this before. When those customers are going to bet, are they going to bet last minute? Are they going to bet earlier in the day? What our competitors do. So we've seen that when a competitor has downtime on Grand National, that we will absorb some of that load, and even the football results can influence just how many people bet. So for this group of customers, we're going to come up with a different strategy. So now we've agreed a target. So a target 16. What we need to do is we need to go through a cycle of test, analysing, tuning and scaling in order to be able to hit these targets. We start off by doing tests against individual services. So we can see what customers are actually doing. They come back in big spikes. We need to replicate that in our tests because systems behave very differently under those conditions. As a rule, we refer to Google's 4 golden signals for analysing the results. And once we've done the individual tests, we start then to do combined tests. Start doing these up to Saturday levels and then up to Grand National levels and beyond. We schedule these at times that are appropriate. There's a bit of risk involved once you start performance testing in a production environment up to these levels. And as we're testing, I've talked about tuning and scaling, and we've got a process behind how we think about this and how we do it. And where possible, we look to offload that, we look to take it out of our own data centers, ideally into the public cloud via caching or hosting applications in AWS. We look to do stuff quickly so we can work out how much a particular call or service costs, and where possible we look to reduce that cost by database tuning. Indexes, very common. The final thing we do, and this is the most expensive thing to do and often the least efficient, scaling stuff out. So that's auto scaling and pre-scaling. Physical scaling, so looking at our own data centers and hopefully being able to rebalance what we've got so that we make better use of what we've got. In situations where you have a traffic spike, is that auto scaling is often not quick enough. By the time the spikes hit, it's too late, so we do a lot of pre-scaling. And as we're doing this tuning, testing and scaling, we get a really good idea of the technical cost of a service. And in SRE, we work really closely with our commercial colleagues, so we know the business value the service as well. And we start to plot these on a chart a bit like what's in front of you. And what we can then do is look at those things that have got a low business value but a high technical cost and look at gracefully degrading them, ideally earlier in the day, so turning them off or reducing how much they used in order to save some technical resource. The final group of services have quite a big business value, but if we're getting towards the start of the race or just after the race, potentially we can turn them off for a a short period of time. And again, we agreed that up front, had clear run books, which we had practiced, and worked with to do that in a controlled way. But then if you look at that chart, you can see that there's a whole area where it's got a high business value and a high tech cost, and we can't really turn this off. The impact of the business will be too big of a service. We're no longer proud of it. It's not what the customers recognise, and potentially it's not compliant or it's less secure. And for this, we've got to think about load shedding. What can we do with that load? And what we decided to do was use a queue, which Josh is going to tell you about next.
As Matt's spoken about, we wanted to develop a solution that means our site stays available and performant throughout the day, whilst accepting we may want to prioritise the experience of some existing customers as opposed to the customers who only bet just on Grand National Day. So the first point I want to address is how we distinguish new customers from our existing ones. Fairly simply, we're going to give any customer who comes to our site in the 2 weeks preceding Grand National a cookie called Existing Customer Cookie, and that's going to have a value between 0 and 1. So just kind of remember that part for later. We'll do this by using a Lambda Edge response function on our login and homepage behaviours. So anyone who hits the homepage or logs into our site 2 weeks before Grand National will have this cookie set to the device. We will actually remove this function a couple of days before the big day, and so then within that 10 days we'll kind of have every one of our regular customers covered. The second and slightly tougher task is how do we take these two cohorts and send one to the website and yet send another to a queue system. So let's break that down slightly. What technology are we going to use for this? We decided to use Lambda Edge, as this will work well for intercepting traffic right at the top of the tech stack. This is before the request is forwarded on from CloudFront to the origin, meaning we intercept the calls before it hits any security devices, load balancers, or any other applications further down the stack. We could have looked at implementing this logic as a traffic script on a load balancer, but this might not work if kind of during peak times there's actually too much traffic for the actual device to handle it. So Lambda Edge seemed a good choice, as it does have some soft capacity limits set by AWS, but these can be adjusted, so essentially removes our capacity concern. As for the actual queuing logic, one of our partners, Netacea, offer a queuing solution, which basically queues anyone for big events. We've seen it used by other companies. I think over the last 18 months, we've all kind of been put in a queue for event tickets, product release, or even like a supermarket order. So how the Netacea side will work from our point of view, we give them a HTML queue page, so this will actually be the page presented to the customer. And then we also set two variables. So first of which, the zone count, how many people we actually allow to be passed into the zone before we start to queue our customers. So say we set the zone count to 10 customers get to our site, and anyone above that is placed in the queue. And then the second thing we set is a timeout value. How long before we consider a customer session over and their next request then goes into the back of the queue. So again, say we set the timeout value to 2 minutes, customers do their action for 2 minutes, and then they're placed, their next action will be placed in the back of the queue. So that's kind of our queuing logic. We then actually need to develop this Lambda Edge origin request script. This script needs to do a few things. Firstly, it checks if the user is an existing or a new customer by checking the cookie that we mentioned earlier. If it's existing, we pass these requests straight to the origin, so nothing really changes for an existing customer. If it's a new customer, then we actually will do some further checks. So firstly, we're going to pass the required information to be sent to Netacea, so things like an IP or a unique user identifier. And then we're going to send this info to Netacea from within the function, and Netacea will respond to us within the function with either a 200 to say, we've recognized this user as a user and into the zone, or they'll respond with a 503 to say the zone count is full, the zone count that we set earlier, and then this customer will go into the queue and have that HTML page presented back to them. So when Netacea respond with a 200, we send the customer to the origin, adding to our zone count. This also passes an origin response rule on the way back out, which will set some further cookies Netacea have sent back to us in their response. Upon a 503, we return the body of the message from Netacea to the customer, all from within the actual original function. This returns to the queue page and then some additional information like estimated wait time and a progress bar. So the user is actually seeing the queue here, and the request hasn't gone any further than the origin request rule, which takes all our apps further down the stack because we're responding right at the very top. So, and the request rule, we have actually added some additional logic to say if Netacea don't respond or they don't respond in a certain time, then we're going to return a splash page. So the function will set we'll still let existing customers to the site, and new customers they'll put to a static splash page. This is better than the whole function breaking and sending an error for every customer, which essentially brings the site down. So this is just a bit of like an insurance policy we've added in case NetAsea don't respond how we expect to. So that's kind of it on how it works. How did it actually work on the day? Well, it kind of worked surprisingly almost how we expected it to. We kept an eye on the zone count and moved our zone count limit up throughout the day based on how the website was performing. We didn't actually end up queuing anyone until about 10 minutes before the race. And in that time, customers were only in the queue for a couple of minutes, if that. So everything pre-race was running really smoothly. Post-race, we had the plan to cut the zone count down to a really small figure, giving all the priority to existing customers and kind of no new customers taking up that zone count. We did this, and also in the few minutes before the race, we made the decision to only allow 50% of our existing customers to the site and then put the other 50% in the queue. So we did this using the value of the existing customer cookie that we previously set. This is what I mentioned earlier. So we had a configurable line of code in the function saying, if the value is above X or 0.5 in this case, then send that user's request to NetAsea to be in the queue. So there, that 50% of customers is now acting as if they're a new customer. So this means only 50% of existing customers will get to the site. This turned out to be a very good call, as post-race we saw 75% of all users throughout the day return within a couple of minutes. Safe to say we were pretty close to some limits at the site at this point, pretty close to having some big issues. But in the end, we actually managed to find a nice balance between allowing some customers to continue to bet, maintaining service, and kind of giving an acceptable response to those customers who we weren't allowing to the site. We then finished up by allowing all existing customers back to the site, changing that same line of code back to what it was before, and then slowly upped the zone count as we saw numbers of users on the site decrease. Testing showed customers will be in the queue for maybe up to 15 minutes post-race before then being able to navigate the site. An hour after the race, we were completely back to normal. We actually completely removed the function from our site entirely, so we're just back to our normal default state. And everything running kind of smoothly and as expected. So all in all, a pretty successful day.
Thanks, Josh. And as with anything, we learned some stuff on the day. So if we were to have another Grand National in a couple of months' time, and we will next April, hopefully, then there's some things that we would do again, and then there's some things that we would change. And what went well? So our low predictions were incredibly accurate. It was within 5% on every metric of where we thought we could or would get to. So whatever we did for modelling this year, we will try and do that again. Dividing our customers into cohorts. So previous years, we treated a customer as a customer and was all equal on the day, but actually existing customers, repeat customers do have more business and commercial value over new Grand National customers. So being able to separate them out and manage them differently was incredibly valuable. How we test, tuned, scaled and analysed, actually, that's really valuable. We carry on doing that in our SRE team weekly now. We go through this cycle, we learn things, or we just gain confidence in what we already know and what we've done. A bit of advice I give to anyone is when you're talking about run books or you're turning things off or you're doing things that can impact the business, work with them and agree with them how you want to do it. What you think in tech is the best thing to do actually may not be the best thing for the business. And it really helped build relationships. And then finally, load shedding via a queue. There's only so much load that you can take or it's commercially viable to take. And there's not many patterns for really shedding excess load. A well-communicated queue is actually an okay customer experience. So thanks for your time, everyone. If you want to get in touch with me or Josh, you can find us both on LinkedIn. And we're going to publish the code for the queuing system on the following URL.